So hi, my name is Dejan Jordan, and I will be going over the Heap bottom up algorithm and then showing you the code and then the demonstration. My video is not working for some reason, so I'm sorry about that. It's just going to be the audio. So for the algorithm here, this constructs a heap from elements of a given array by the bottom up algorithm. The input is an array of orderable items, and the output will be the sorted array. So the loop starts here at I equal to the n slash 2, the last internal node, and proceeds backwards to the roots. And then for each node in I, the steps would be performed with k being the current index being checked. And then we have j equal to 2k, which would be 2 times k, which would be the left child of k. And if there are two children, j plus 1 less than or equal to n, and the right child is larger, we will update j to j plus 1, which would be the index of the larger child. And then if b is greater than h here, j, we will set the heap to true, meaning that the current subtree satisfies the heap property. Otherwise, the else statement here, move the larger child to the parent's position and continue. And then after the loop, the array is a valid heap. So moving into demonstration. One second, let me see, how can okay, so here I have the code for the heap sort bottom up. So in the heap property, for every node in I, its value must be greater than or equal to the values of its children. So with the bottom up construction, the process starts from the bottommost internal nodes, and then moves upward, ensuring that each subtree satisfies the heap property. So here where I define heapify, initializes the largest root here, largest equal I, then have my left child, left equal to times I plus 1, and the right child 2 times I plus 2. Then this if statement checks if the left child exists and is greater than the roots. If left is less than E, then the largest equal left. Then this checks if the child exits and greater than roots. So if right is less than E in the array, then the largest equal right. And then this if statement checks if largest is not root, swap and continue heapifying. So if largest is not equal to I, then it continues to like heapify. Here builds my max heap for I in range. And then here extracts elements one by one for I in range and then swaps current root with the end. And then he heapifies the reduced heap here. Then I have my example. So my data that I used was 32, 11, 4, 22, 13, 7. So when we run the code, okay, so I do have in my original 32, 11, 4, 22, 13, 7. Gonna change a number here, 13 to 18. I'm gonna change it to 8. And then you can see here, my sorted array would be 4, 7, 8, 11, 22, 32. So the time complexity for this algorithm or this code will be big O n. That's like the average case. Um, this algorithm does like process nodes efficiently due to the decreasing height as we move up to the tree, but also for the worst case complexity, it would still be big O n because it is in reverse order. And then it's like recurring the maximum number of comparison swaps. And it grows like linearly with the size of the input array. So like overall, the time complexity will like result in a linear time complexity of big O n, and like worst case and average case.